Okay, so we're going to go through a lesson that's pretty straightforward, so in fact we'll only do one example at the end. So the question we want to answer is if I have this interval a to b, and I walk along this curved path along f of x from a to b, what is the length of this curved line if I were to straighten it out? Now, obviously we can't just measure it with a ruler, but we can use ideas from calculus to make it pretty easy. So what we're going to do is we're going to zoom in pretty close to the graph. If you zoom into any curvy graph close enough, it will eventually look like a line, a straight line, and we can work with straight lines pretty easily. So let's assume that this tiny piece of the graph has an arc length that we'll call delta s. If you remember from pre-calculus, arc length, they use the variable s for whatever reason. Okay, so we can actually draw a right triangle from this, and we'll call this delta x, that's a small change in x, and we'll call this delta y, and that's a small change in y. So here's our plan. What we want to do is get an expression for delta s, which is a little piece of the arc length, and then we're going to add up all the arc lengths using an integral. So by Pythagorean theorem, we can say that delta s quantity squared is equal to delta x quantity squared plus delta y quantity squared. So I'm going to do a little bit of algebraic manipulations to kind of get this in a certain form. What I'm going to do is I'm going to factor out a delta x quantity squared from the right side. So out here will be a delta x quantity squared. Okay, so if I factor it out of the first term, delta x squared over delta x squared is just 1, plus if I factor it out of the second term, that actually turns into a delta y over delta x quantity squared. If you're unsure that this is true, go ahead and distribute this back and you can verify that. So now I'll square root both sides, and what I get is that delta s is equal to the square root of 1 plus the quantity delta y over delta x squared times delta x quantity squared, which I know that'll pull out of the radical. So let's simplify it even further. So delta s is equal to the square root of 1 plus delta y over delta x quantity squared, and then I have a delta x that goes outside of the square root. What we're going to do is we're going to let delta x shrink to 0, which basically means that the gap in our interval is going to be very small. If we do that, then what happens is all of the deltas turn into differentials. So instead of 1 plus delta y over delta x quantity squared, we get 1 plus dy over dx quantity squared. And that delta x turns into the differential dx. That's a single little arc length. So what we're going to do is we're going to add up all the arc lengths to get our total from a to b. And this is the formula that we can use, believe it or not, to calculate the length of this path that I highlighted in red from a to b. Okay, so let's just use it in one quick example and then move on. Okay, so let's take a look at 3x squared plus 1 from 0 to 5, which I know is some sort of parabola that looks like this. And what I'm looking at is what is the length of the arc from x equals 0 to x equals 5. Okay, so if we just use the formula, we actually need to only find one thing. Since y is equal to 3x squared plus 1, its derivative dy dx is equal to 6x. So we have everything we need because this 6x is just going to go in here in the formula. So the arc length is going to be the integral of the square root of 1 plus dy dx squared, which is just really 6x quantity squared times dx, and the bounds are going to go from 0 to 5. Now in some textbooks you're going to work this out by hand, but just go ahead and calculate on your calculator to get your final answer.